Okay, so last video we drew the nut and we're going to put that taper pin through it after we have assembled it. Next, why is that not doing what it's supposed to do? There we go. All right. Number 3, let's have a look at this thrust bearing. So the thrust bearing or thrust washer, it's got an upper and lower plate, and it's got a whole bunch of ball bearings so that it can swivel. So the hook essentially can spin freely independent of those cheek plates and the lifting mechanism. Okay, so how do we draw this one? Let's look for some clues again. We've got an axis line in the middle, so they're obviously round. The other thing that tells me that it's round is these diameter symbols. 38mm hole in the very center there. So that 38mm hole will work with the 36mm thread to go through, and it'll sit on this part of that hook. So the guts of the hook will go up in there. Let's see, total 28 high. Each of the blocks or plates are 10mm thick. So if that's 10 thick, that's 10 thick. There must be an 8mm gap in the middle to give us that 28. The ball bearings, they have a diameter of 10mm. Okay. All right, I've got a plan. And I had a crack at drawing it last night too. So here we go. Off to new. This should be a bit quicker this time. Doing a 2D sketch, and we're going to put it on that XY front plane again. So let's draw a line, make it a center line, start it from that 0, 0, and a bit of fun, let's make this 28mm tall. Just type in 28, press enter, job done. Escape to stop it drawing a line. Turn off that center line component and let's draw a rectangle. This rectangle, I don't know exactly how wide it's going to be at this point, but I do know that it's going to be 10mm tall. So if I use my tab button, it changes which dimension I can change or set for my rectangle. So tab button swaps between the two. The one that's blue is the one that I can type into or set. All right, so that one's 10mm tall. I'm going to need another one of those down here. Same deal, it needs to be 10mm tall. Tab button, type in 10, hit enter, happy days. My horizontal constraint, the top. So I'm going to use the center point of that top of that rectangle. It needs to line up with the top point of that line. Take the bottom edge, center point of the bottom edge of that bottom rectangle, and line it up with the bottom of your center line. Now for some dimensions. From this edge of my rectangle, yes, I know it's 10mm tall. However, if I click on that center line, also, it gives me this dimension. Now that needs to be, what is it, 38mm. Type 38, that's line. These two line up on the inside edge. So I can use my vertical constraint. So look, take the center of that line and line it up with the center of this line. They must always line up. A couple more dimensions. This edge, this is going to govern how wide that top plate is for this thrust bearing. It's 72mm in diameter, and the lower one is only 70. Okay. All right. The other thing I want to put in here is that where that ball runs, because we need to make the race that the ball follows, or all of the ball bearings follow. Okay, so let's pop a circle in here. I'm just going to put it not really constrained to anywhere at all. 10mm in diameter. That's the only thing I'm going to tell it at this point. Horizontally, I want the center point of the ball to line up with the center point of my axis. And if I look back to the drawing, it tells me that the ball bearings are running on a center of 54mm. So if I dimension from the center point of the axis of the ball bearing back to my axis line, this one up here, that had to be 54mm. so it's in place. Now what I'm going to do is I'm going to use this sketch twice. The first time I use it, I'm going to sketch out the top washer for the thrust bearing. Second sketch is going to be doing the revolved extrusion for the lower washer, and we'll draw a ball bearing separate later on. Okay. Sometimes, I don't know why, we'll just see if this works this time. Now, revolve command, we've used that a couple of times. What is the profile? I'm just using this top one. You see how it hasn't picked up where the circle is running through? I'm going to have to trim out this section here. All right, cancel that. If I want to go back and modify a sketch, all I need to do is click on the icon for that sketch, and it will open it back up and I can keep working on that sketch. Right, the trim tool here in the modify section of your toolbar, we have a trim tool. Now the trim tool let me cut out that dotted section. So wherever I put my cursor on, it will trim out that section. So it's looking for where something's cutting through, and it's cutting that bit out. You'll notice these two bits have gone green. They're unconstrained now. The reason for that is they have forgotten that they're actually in alignment with this bit. So if you find the center of horizontal constraint, find that horizontal constraint center and there. So you could line it up that way, or you could dimension this one to this one and tell it that it needs to be 10 millimeters. That will also fix it. So it knows how big this side of that rectangle needs to be. A couple different ways of doing that. Okay, now back to here. Finish the sketch. Do a revolve. Profile, top section. What is the axis? Here's my axis line. I'm just going to put that one in. Say, okay. Material. Let's make this out of stainless steel. Let's just use the generic stainless steel there. Now you'll need to save that part. So you go File, Save As, and we'll call it. Now this is all part 3 to make the whole thrust washer. So you see here I've got 3A upper ring. So that's what I'd name this one. We'll just imagine we save it here. What you're going to do is you're going to come back to that part that you've just drawn. We're going to modify it. We're going to use that same sketch again. This revolve I did, I don't want it anymore. I'm going to delete that revolve, but before you hit OK, untick that consumed sketch. I don't want to delete the sketch. I need to keep that. All right, so I've still got my sketch. Now I can go back to revolve and this time choose the lower profile and the axis. And OK, so I've just now created the lower one. Go to File, Save As. It's very important you go to Save As, and now save this as 3B, the lower ring, because if you just hit Save, it will save over your upper ring. Okay, so like I say, it's really important to get into the habit of going to Save As so you don't accidentally save over things you've already drawn. Okay. So that's those two components drawn. The next component I'd be looking at for this thrust washer is the ball. And it's interesting, I said to one of my colleagues just this morning, said, well, how would you draw a sphere? And his response was, well, I'd just draw a circle and I would revolve that circle to make a, what have I done there? Talking, not thinking. Revolve the circle to make a sphere. There's a problem with that. If you take a circle and try and revolve it around its own axis, it's drawing over itself and it has a big problem with that. So what we're going to do is we're going to draw an arc, and if you use this center point arc, it's just like using a compass. First of all, it wants to know where are you putting the point of your compass down, where are you putting your pencil tip down, and what size. So it's looking for a radius here. That's important to remember. If you're drawing an arc, it looks for a radius. We only want to draw 180 degrees of it, not the full thing. And Then we're going to go top to bottom and complete the shape and finish that sketch. All right. Then we're going to revolve that. It's chosen the shape. The axis is the line. And there's my sphere. Change the material to be a stainless steel material and save it as part 3C ball bearing. Once you've got all those drawn, we can put them all together and we'll have a look at that in the next video. So go and have some fun creating those bits and pieces.